My name is Elijah Welch. I'm the district engineer at the Richmond Sanitary District. I've been there about 8 years, and the engineering department is responsible for all the capital improvement projects for the Richmond Sanitary District, including sanitary sewers, some storm sewers, and the wastewater treatment plant.
This project primarily focuses on replacement of the east side interceptor, which is a large diameter sewer servicing the large majority of Richmond. That sewer was old. It was built in the 1930s. It was made of reinforced concrete. There were sections of the east side interceptor that had failed, and there were sections that actually surcharged during wet weather events. This project in particular is very unique because you're combining the long-term control plan, where a lot of alternatives were analyzed, and trying to come up with that solution that is the most cost-effective and from a long-term standpoint is going to do what we want. It wasn't a matter of just saying, here's a line on a piece of paper where a pipe goes. There's a lot of decisions as to where the pipe should go, where we should pick up interceptors, where we should pick up regulators. So this is a very complex project. From the surface, it may not look like it, but there's a lot of background planning that's involved in a project like this. Part of the work that Commonwealth did is they performed extensive hydraulic modeling to assess alternative configurations of the sewer and other improvements to be done in the city. After that planning level, design took place. We broke the project up into 3 manageable phases. Phase 1 was primarily open cut, Phase 2 was tunneling, and Phase 3 will be a combination of open cut and tunneling.
This is a very unique project for Richmond. It's the first major tunneling project that we've done, and it's definitely the deepest sewer that we have in town now, at just over 70 feet deep. This has been an interesting process and project to work on, and it's definitely something that will go down as one of the bigger, better projects that Richmond's seen.
The biggest challenge to date is Phase 2. Phase 2 involves tunneling. The tunneling aspect definitely is an area the city hasn't really done in the past extensively. And the other big challenge with Phase 2 is connecting to their existing regulator, which is 50 feet below ground. As we can see here in Structure 208, where this is the tie-in point to the existing east side interceptor, and upstream of this is a regulator. So between the regulator and the tunneling, those are probably the biggest challenges as of date. The reason we had to tunnel Phase 2 is the existing east side interceptor is installed on the slope of a very unstable hill, and in the past that pipe has failed. We assessed open cut technologies and approaches to see if we could replace the pipe in kind, and the risks to that pipe in long term would be too high for failure. So what we chose to do in this case is tunneling within the streets of Richmond, away from the sloped hill, to provide a more long-term solution for the city.
Once this project's complete, we expect to see less surcharging in our east side interceptor, but we have to realize and keep in mind that this is only a small piece of our overall CSO long-term control plan. So this is a piece of that puzzle, and there's a lot more that has to happen, but this is definitely a step in the right direction in completing the work on our CSO long-term control plan.
This project positions Commonwealth to do more projects related with tunneling and helping communities that have aging infrastructure, whereby tunneling is a cost-effective way of increasing capacity and replacing aged interceptors.
The project's definitely been successful, and we're happy with the outcome that we've had to date.